Okay, 14.4 is going to be a little bit different than what we've been doing. We've been taking the derivative of things that were all nice and neat. They always say y equals or f of x equals, and it's easy to take the derivative. But sometimes we'll have a function that isn't in y equals form. Maybe it's got y cubed, maybe it's got y to the fifth, it's got xy squared, it's got something that makes it difficult to put in the y equals form. If that's the case, we have to use this process called implicit differentiation. So it's a process where it's not easy to get y in terms of x. And I've got the rules here. You're going to differentiate both sides of the equation with respect to x. With respect to x. Then you'll put all the terms that have a dy dx, and you'll see what we mean, on one side and everything else on the other side. You'll factor out dy dx, and then you'll be solving for that. And you're thinking, maybe, if your thinking's on today, you're thinking, where's that dy dx come from? What is it? If you take the derivative of y with respect to x, you have to attach a dy dx. In other words, I'm going to write this right here. If I said y cubed, and you're thinking the way we've been taking derivatives, what would be the derivative of that? 3y squared. Okay, but this is with respect to x. So the derivative of that would be 3y squared dy dx. You have to attach a dy dx if you're taking the derivative of anything other than x. Okay? So every place in the equation that there's a y, it's going to have a dy dx on it. Okay? Maybe we'll see that when we get, here's an example. Find dy dx, which means derivative, if 3xy plus 4y squared equals 10. Okay? First thing you have to note is that 3xy is a product. So we'll have to use the product rule when we do that one. So we're going to take the derivative of both sides. That's what that first line is. Derivative of that equals the derivative of that. And then I've done this in parts. You won't do that in your real work, but I just wanted you to see the derivative of 3x is what? 3. The derivative of y is 1, but you have to attach a dy dx. So the derivative of y is 1 dy dx. The derivative of 4y squared is 8y dy dx. It's not really bad if you just get in your head, every time I take the derivative of a y, I got to attach a dy dx, because this is about respect to x. Okay? So, all these little derivatives that I took are now going in here. The derivative of this one times the derivative of y plus y times the derivative of the first part. This is that product rule. Plus 8y dy dx. So in that line, all I did was take each derivative, which I had done here. I just plugged them in. Everybody okay with that so far? Here, all I did was multiply these and multiply these. So I didn't multiply those. So I have 3x dy dx plus 3y plus 8y dy dx. I'm just multiplying, distributing, whatever I need to do. Where did this 0 come from? The derivative of 10 was 0. Okay? Then that rule said, get all the dy dx's together, put everything else on the right. So I moved the 3y to this side. Okay? Then you're supposed to factor out dy dx. So if I pull out dy dx, I'm left with 3x plus 8y. Everybody seeing that? And what am I solving for? I'm solving for this guy. So I'm going to divide by 3x plus 8y. So the derivative is negative 3y over 3x plus 8y. Y'all have a question, Holly? You got it? Okay. So every place that you take the derivative of y, attach a dy dx. Product still in, you have to use product rule if it's a product. Quotient rule if it's a quotient. Then get all the dy dx's on one side, everything else on the right. Factor out dy dx, divide or whatever you need to do. Solve for that, and that's your answer. Okay? Everything applies. It's just that if it's y, you have to have a dy dx. All right. So let's go look at the problems. They take a while. Some of them are pretty long. Okay, I think that's the first one. 7x squared plus 9xy plus 9y squared, blah, blah, blah. If it didn't say, if you weren't on this chapter and you just saw this on the final, some people say, well, how do I know if I have to use implicit differentiation? If you've got something besides, if you don't have y equals and have it nice and neat, you're going to have to use implicit. Okay? All right. Only where there's a y. So like at 9y squared, that becomes 18y dy dx. On the 10y, 10 dy dx. In the product, where you take the derivative of y, right here, you're going to have a 1 dy dx, which is why you end up with this. So everywhere there's a y, you're going to have that. My voice probably faded on that video.
If y is the only variable, and you treat it like x,
well,
it's when y
only
is another variable that you have to use differentiation?
It depends on what you're asked to do. We're asked to differentiate with respect to x.
Okay.
Now, when we get to 14.5 and we're doing these related rate problems, we'll be differentiating with respect to time. So we'll have x's and y's, but it'll all end up with a dt because we're doing it with respect to time. That's why we're learning how to do this so that we can do the word problems. Okay? All right. So we had 14x, that's the derivative of 7x squared. We have this product, so that's 9x times the derivative of y plus y times the derivative of 9x, which is 9. And then we have 18y dy dx, that's from there. 10, why do I not have a variable? I just have 10 dy dx. That came from here. Why do I have that? What's the derivative? What would be the derivative of 10x? 10. So the derivative of 10y is 10, but then I have to attach the dy dx. And then we have 0. Okay? Then I kind of just multiplied if I needed to. I think that was just that step there. Okay? What I have in yellow here are the only things that don't have a dy dx attached. Those are the guys getting added to the other side. Get rid of them. They don't have a dy dx. So those got subtracted over here. What's left are these three things. They all have dy dx. Factor it out. So you're left with 9x, 18y, and 10. If I'm solving for the derivative, which is dy dx, divide this whole thing to the other side. There's your derivative. It looks much worse than it is. It's really not too bad once you get going. Questions? Anybody? Okay, let's look at 2. There are 2 ways to do this problem. This may or may not be the easiest way. I just took the derivative of both sides. You could multiply this thing over here, and you'd have a product on one side and everything, but the quotient rule, you can do it this way. You can look at it. I might put the alternate way up there. I think you'll be okay. Well, that's what I got. I don't know. Do y'all have the answers on your sheet? I don't either. I don't know where they are. We'll have to look and see. I'll double check on that. But let's look at what I did here. Okay, if you take the derivative of this guy, you get 6y dy dx. Over here on the quotient rule, it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Okay? And this one was okay over here because it was all x's, so that's nothing new. On the top, we have 16x plus 20 minus 16x plus 20. Watch your signs. So the x's cancel out, and you're left with 40 over 4x plus 5 squared. If I'm solving for dy dx, I'm just going to get rid of 6y. And when you divide it over here, it just goes on the bottom. What happened between here and here? Divide by 2 on the bottom and the top. 20 there, 3y there. Questions? Anybody? Yes, if I divide 40 by 2, I get 20, and if I divide 6y by 2, I get 3y. It's what would go into both of them. You're just looking to how can I reduce 40 over 6. That's what you're thinking. Okay. Do what? With that 2, you can't because it's being squared. It's kind of isolated in those parentheses. Okay. All right. Everybody good with that one? All right. Let's look at this one. When you see those square roots, the first thing you want to do if you are doing derivatives, you want to rewrite that as x to the 1/2. So go ahead and get that rewritten. So now you're going to take the derivative of each of those pieces. There's not a product, so this is pretty straightforward. The derivative here is 1/2 of 8 is 4, x to the negative 1/2, plus 1/2 of 12 is 6, y to the negative 1/2 dy dx. Got to plug the dy dx on there. Equals 5 dy dx. So you just take the derivative of each piece like we've been doing, except where there's a y, we got to have that dy dx. This is the only piece that doesn't have a dy dx, so I'm going to leave it by itself, and I'm going to subtract this 6y. So subtract that over here. Then factor out dy dx, and you're left with 5 minus 6y to the negative 1/2. And then divide this whole thing to the other side. Then we want to change it back to the other form with the radicals. Why do I have 4 over the square root of x? Right, this is a negative 1/2, so it's not only square root, but it's on the bottom. So 4 over the square root of x. And this is 5 minus 6 over the square root of y. But I think in math lab they want you to go a little bit further. So what you have, actually you can have, here's a thing down here. This is like 5 over 1, and if I want to make that one fraction, I've got to combine these two. What's the common denominator? Square root of y. So if I multiply square root of y over square root of y, I get 5 square roots of y over the square root of y. Does everybody see that? That's that basic algebra doing fractions. So now I've got one fraction over another fraction. And when you divide fractions, what do? You flip and multiply. So that's what's happening here. I flipped this one, and I'm multiplying. And I end up with 4 square roots of y over the square root of x times this thing. And I believe that's what they want in math lab. It's kind of crazy. But now that you have a format to follow, you'll be okay. Do what? Oh, sure. Is that good?
Exercise your algebra.
You do. You really do. And it's why this is a good spot for a collaborative test. It's really good. Can I move it up now, Akivia? Okay. Or down, or whichever I'm moving. You really need to be familiar with radicals and fractional exponents, all of that, to do well on this. On the test, remember that I'm going to be grading it, not a computer. So if you had it not totally simplified, it's probably going to be okay. But you should be able, and I don't know that you have one quite like that. Okay. Yes, sir.
The answer for it?
Uh-huh.
Which one would be the answer?
In the red? Oh.
Choice.
Oh, it's multiple choice. I don't have anything that looks like that. It looks like it's D, it's turned around, so it's got that negative. Right, but if you multiply that negative on that, but see how mine is square root of 5y minus 6, and they've got 6 minus 5 square root of y. So if you multiply the negative there, it's going to flip those signs and be what this is. Does that make sense? Because you've got that negative out front in the multiple choice answer. So if you multiply that negative, it's going to flip these around. And you should get what that is. Okay. I must not have looked at the answers when I did that. Sorry. Okay. Let's look at 4. We get back to writing the equation of the tangent line. Remember we said we're going to have those all the time? And we've got an equation that says x squared y squared equals 9. Write the equation of the tangent line at 1, 3. Well, we can't do math 8 because this is not y equals. We can't, the function's not in the right place. So let's go ahead and take the derivative of this guy. Okay? The derivative of that guy. X squared times the derivative of y squared. Plus y squared times the derivative of x squared. So that's my roadmap for that. So I have 2x squared. Where did that come from? 2 times x squared y dy dx. Okay? Plus 2x y squared. That's just kind of moving stuff around. This one is not a dy dx, so subtract it to the other side. And then divide by this piece. So you have dy dx equals this over this. And if I were doing a final answer there, I would get rid of the 2's. I would do some things. The x's can, you know, there's a lot that you could simplify there. But what am I trying to do? I'm trying to find the derivative at a certain point. So I don't really have to worry about that simplifying. What am I going to do? I'm going to plug in the point I was given. I was given 1, 3. Well, that can go in for each of those x's and y's. Negative 2 times 1 times 3 squared over 2 times 1 squared times 3. And if you do the math, you should get negative 3. That's our slope at that particular point. So, taking the derivative, evaluating it at the point. The only difference is you have to plug in x and y because you have x and y in your derivative right here. Is everybody good with that? Seeing how we plugged in to this guy and that we get negative 3 for our slope. What do you need to write the equation of a line? You need y1 and you need x1 and you need m. Do we have all that? We do. We have right here, and right here. So the last part of the thing is to use that equation, fill in the parts you have, and get that equation. We good? All right. Same thing with number 5. Here's your equation, 2y squared minus the square root of x equals 5. We want to know the equation of the tangent line at 16, 4. So I would rewrite this as 2y squared minus x to the 1/2 equals 5. And then take the derivative. So when you take the derivative of 2y squared, you get 4y dy dx minus 1/2 x to the negative 1/2 equals 0. Okay? We're going to add this part to the other side of the equation. And then we're going to divide by 4y. What did I do here? How did we go from this step to this step? Well, this x to the negative 1/2 became this, square root of x on the bottom. This 1/2, the 2 went to the bottom, and we already had 4y. So I just simplified that to this piece right here. Okay? Everybody okay with that algebra? All right, so what do we do from now? What's our next step? Plug in the point in this derivative to get the slope at that point. So we're plugging in x is 16, y is 4 into this equation. So we have 1 over 4 times 4 times 2 square roots of 16. If you do the math, you get 1 over 128. And in math lab, they're going to want fractions. So if you're trying to do it with the calculator, you have to be able to have fractions for the equation. You might as well just work it. Okay, so we have m, we have y1, we have x1. So we're going to put that in the equation form. It does require some algebra. If you can do it on the calculator and get the same stuff, go for it. But I think you may run into a little bit of trouble. Add y minus 4. Here's your slope, x minus 16. When you multiply, you get this. Add 4 to the other side. What did I do here? Where did this 512 over 128 come from? Changing 4 into a fraction that had 128 as the denominator so that I could combine those two pieces. And then I reduced it to 31 over 8. Okay. So, same steps. You're taking the derivative, evaluating it at a point, putting it in the point slope form. So, I want to walk around and I want you to work on number 6. Number 6 is the same thing. Everybody have their sheet so they can get the problem? It's there at the bottom if you don't. And number 6 says, find the equation of the tangent line at the given point. What is different about this one and the ones right before it? You don't have a y value. So the very first thing I would do would be to plug in x in the original and get that y value. So you guys try that. So you should have gotten the point to be 1, 2. And then let's see if we're on right track for the derivative. See if what you were doing. Sometimes there's different ways to attack a problem, but ultimately we got to end up in the same place. Anybody come up with that? Or on the road to coming up with that? Did you get it? Good. What's your next step after you get that derivative? Plug in the 1, 2. So 1 for x, 2 for y. There's a good bit of room for error in these kind of problems, just the algebraic work. So that's why when you're working together, you're going to help each other get through it. Yes, sir?
Where'd you get that Y?
The y.
128 minus Y.
You brought it from the other side.
From the other side? Yeah, let's move back up a little bit. This y? Right here? So it's being added, so you subtract it to the other side?
Why doesn't that with dy dx on?
It was part of,
Like the original.
that was a product. And so you have that times the derivative of that, but you also have that, y, times the derivative of x, which is 1. So you end up with a plain old y.
So whenever you're doing like the second part of the product,
Uh-huh.
you can still just keep y, but not.
Yeah, because you're not taking the derivative of it. You only, yeah,
Which is 1.
right.
And then you, okay.
Yeah. So that's when it's really important to maybe write the roadmap so that you know it's y times the derivative of x. So if you're not taking the derivative of y, you don't have a dy dx. So that becomes maybe a good place to do that. That's a good question. Good question. So we have a slope of 21/8, and we had a point at 1, 2, and so your equation should look like that. And that's the way you're going to have it for MATLAB. And I really think at that point, a calculator, you could try working with it, but you might as well get used to doing the fraction stuff, because that's what you need to have. Okay? What if you got m to be 0? What would that tell you?
Horizontal line.
Horizontal line. Yeah, if 0 was on the bottom, it'd be undefined, and what kind of line would that be?
Vertical.
Vertical line. So that's certainly a possibility. Just keep that in mind. Okay, any questions on these? You've got, what, 6 questions? You've got 6 questions on MATLAB. So what we're going to do is be done with this.